Hello everyone, my name is Garen Phillips and today I'm going to be showing you how a 3D printer works. I'm also going to be talking about my Mendel Prusa build, and this will actually be the first video of that build. This here is the pieces that just got done printing in our 3D printer at our shop. This is the other pieces from the first pallet, and this is all the stuff that I had bought in order to make the Prusa Mendel. And for those of you who might not know what this is a open source 3D printer that you can find online. It's called a RepRap, and the version of the RepRap is the Prusa Mendel. You can check that out at reprap.org, and for the Mendel Prusa you can just click on it. It'll be on the main website. But I will also explain how a 3D printer works. And I'm going to start with the mechanics of the printer and then move on to the electronics and how they control the mechanics, and then from there I'll go to the software and how the software is sent to the electronics, and the electronics interpret the toolpaths that it creates. So let me take this palette out of here. And one of the cool things about this 3D printer that the RepRap doesn't have is support material. Now I don't know if anyone's developed a RepRap with support material. It'd be cool to know if someone has. But one thing that I like about the RepRap is the material is going to be much cheaper than this printer, but I don't know about accuracy. I'm going to have to tweak it in order to hopefully be able to print stuff this accurate. I don't know if it'll be possible. One of the cool things about the RepRap is that since it's open source, it's constantly being updated and improved, and people post their builds online, so it's a constantly evolving platform, whereas this, we can't do anything to it because we bought it from a company. But here I'll show you how this actually works. Here is the printing head. There's a heater inside the head that melts the plastic, which is ABS, to 300 degrees, and then it's extruded out right here. And then it's laid down on the pallet, and how it creates, or how it moves, is it has a X or Y, I'm not sure which axis this is. I'll just call it the X axis. So this bar right here is the X axis that it runs on. The Y axis is here. You can see that there's belts right here, and these belts are connected to a stepper motor, which one is right here, and there's another one over here in the printer, and you can see the belt here. Let me grab my light so you can see a bit better. Okay, so there's the belt, and then there's a idler pulley way back there that the belt rides on. And then for the Z axis, which is up and down, there's a ball screw actually. There's the threaded rod, and there's a ball screw here. I don't know, you probably can't see it, it's probably enclosed. And then there's a stepper motor down on the bottom side of the case down here. And how this works is the stepper motors, which I can actually show you on here. I have some for the 3D printer that I'm building. The stepper motors work by taking a signal, and that signal is considered one step. So each step can be calculated to a certain number of degrees rotation, and then if you have a belt connected to this motor with a gear, you can calculate how many rotations for a linear movement per inch or per millimeter or whatever you're setting it up for. And on the ball screws, you can calculate how many rotations there is per inch, and that will give you a linear motion for using ball screws. So that is the mechanics behind a 3D printer. If I missed anything or I forgot something, feel free to comment, and I'll try to update it and put a caption in on the video. If you're watching the video and you're new to 3D printers, I would suggest that you turn on the captions, because a lot of times I update my videos if I've screwed up or anything, and I don't want to give anyone any inaccurate information. And now I'll explain to you the electronics behind the 3D printer. And I am new to the RepRap, so if someone's watching this from the RepRap community or the Arduino community, please correct me if I screw up anything, because I don't want to give out incorrect information. but from what I've read and understood, the electronics and how they work is for the RepRap. It uses something called an Arduino board, and for anyone that doesn't know what this is, it's actually a pretty cool piece of hardware, and it's actually a prototyping circuit board that you can interface with on your computer. This is the Mega 2560. It's made in, or designed in Italy. I don't know if it's actually made in Italy, but how this works is you can actually plug a USB cord into this board and connect to it to your laptop, or you can run it independently with a power supply, and this will take anything that you send to it from the computer and send it as outputs, or take inputs from various sensors, heat sensors, thermal sensors, distance, infrared, anything that you want. And I've actually seen some pretty cool videos on these boards online and things that people build. I've seen robots controlled by iPhones and giant snakes that have multiple articulations and all kinds of stuff that's really cool. So you can YouTube just the Arduino, and you can probably find some pretty cool videos on it. And you can also visit their website. I'm not sure what it is. You can Google it and find it pretty easily and download the software. The software that runs this is actually script based, so if you're new and you don't know anything about script, I would actually suggest you start with this, because this is an extremely simple script to learn. It can be used for more complex stuff, but for the basics, there's a lot of tutorials and stuff showing how you can get simple LEDs to work and stuff. But how this works for the 3D printer is the software for the printer creates a toolpath, and I won't talk about the toolpath now. Once I go to the software, I'll talk about it more. But it sends the toolpath to this board, and the board processes it, and it sends it out in these pins. And each pin is set. You can see that one's ground. Then PWM is pulse width modulation. I won't explain what that is, but if you just search PWM electronics, you can understand what that is. Communication ports, digital ports, and analog ports, and then you have some power to grounds. And once this interprets the signal from your computer, it then sends it to this board, which this board just plugs into the Arduino through the pins. And this is the called ramps, and I believe this is loaded with a firmware for the RepRap, and it is also the stepper motor controllers. And you hook up the stepper motors to this, and then it sends the signal to the motors, like I spoke about earlier, and it will send a certain amount of steps for whatever it needs to do to move in the X, Y, or Z plane. And that is how the electronics works. If I missed anything on that, please feel free to correct me. And for the software, I will go into my office and show you the software used for this, and hopefully I can show you the software for this, but it's actually loaded on another computer, so I don't know if I'll be able to video it. Okay, so here we have a model that I've imported in, and this is the software used for the 3D printer that we currently have. This model is actually a STL file. I can orientate the part. It's already sitting the way I need it, so I don't really have to do anything. Then I just hit process STL, and what this does is the software actually takes this part and it will cut it into slices from the Z axis, which is up and down. And when you look at the 3D printed part, you'll actually see that it's in layers, and that is how it was sliced and printed on the Z axis. So when you look at a 3D printed part, you can actually tell how it was printed just by looking at the layers. They will be parallel to the printing surface. Now that the software has cut the STL, it's created the toolpath for the support material, it's created the toolpath for the model material, and then if I go to the pack, actually I have to pack, or add it to the pack, and it has sent it here, and this is the layout for the palette on the 3D printer. So I can lay these out. Now I'm going to import the rest of the models that I've already processed through the software, and I'm going to start the printer. And I'll also show you the model that's been sliced and cut. Okay, so now that I have the files imported in, I just have to separate them a bit, and the only reason I do this is because the heat from the models can actually warp the parts if they're too big, or especially when they're printed on a flat surface, it can kind of warp the flat surface, such as the bearing plates or the faces at the end of the blower housing. And once they are separated and I have them the way I want, I can see here that it's going to take this much modeling material, this much support, and it's going to take 24 hours to print. Once everything is the way I want it, I can actually create another CBM, which is files that the printer uses. I can save it and call this palette blower 1. And I could also put 2 blowers on here if I wanted to, because it has enough room, but for time I'm just going to leave it as 1, because then I'd have to wait for 48 hours for it to be done. And now I just hit print. It is merging all the files together into one. And now it is sending it to the printer, and we can walk out and start the printer up. And you can see here that the job should pop up. There it is. And it's waiting to be printed. So let's go check out the printer now. Okay, so here we can see that the printer is waiting. It has the blower pallet loaded, ready. This is how much materials left: 57% model, 85% support. Asking to start the model, and I've got some other options. I need to load a pallet into it first, so I need to grab one of these pallets. Put it in here, they slip in and lock. And I'm actually going to purge the head real quick to make sure that it's running, so I don't waste a bunch of time. So I'm going to stop the video real quick and do that. Okay, I just purged it, so now that it's ready and it's good, I'm going to just hit start. And now it's going to try to find home and heat up the nozzle, so it's going to take a minute. And while the printer is doing that, I'll show you what the inside of one of these parts looks like. This is a blower housing of a half scale that I was printing, and we got a power surge, and that shifted the X or Y axis motors off somehow. But this is what the inside of these looks like when you print in a honeycomb. I believe this is sparse, or it might be high density, but I can't remember. High or low density, but this is what it looks like inside. This saves a ton of material. Now, this printer, once it starts running and laying down the material, it will take the coordinates that the software created, and that is how it lays down and knows what to draw on the pallet. It's just like a regular printer. It just has a table that moves up and down, and it's taking hundreds of X, Y, and Z coordinates at once. Well, actually mostly just X and Y. Z only moves once the layer is completely done being laid out. But this printer over here will work the exact same way. The stepper motors will take the inputs from the software and lay down the material the exact same way. So hopefully that gives you a bit better understanding of how a 3D printer works. If I have missed anything, if anybody from the RepRap community or from any other 3D printer communities, if you would chime in on anything that I might have missed or screwed up, I will try to correct myself on the video. But now I will actually make a time lapse of the 3D printer printing the blower for anyone that's interested. I'll make it a separate video just to save a bit of time in this video. You can subscribe to my YouTube channel for more manufacturing videos, like us on Facebook, and visit our website at diamondp.com to help me make more videos.